Let's turn our attention to frames and machines. They are closely related to trusses, but they are not trusses. And by the time we're done with this lecture, you should be able to draw a free body diagram of a frame or a machine and its members and determine the forces acting supporting the frame or machine and within the joints and members of that machine. As usual, there are more slides to look at than what I'm showing you. Please do go through them on the course website because they're example problems, group solving problems, where you can learn more about this concept. And of course, there will be quizzes as well. What applications are there for frames and machines? Well, here's an application of a crane. And usually frames are used to support some kind of external load. In this case, it looks like there's not really much of a load. It looks like there might be rigging hanging off the final hook of this crane. But this crane can be used to raise and lower loads. So how is a frame different than a truss? I mean, this looks a whole lot like a truss. Well, we'll determine that because there's a common difference between frames and machines versus trusses, and then frames and machines are themselves different from one another, but they all look like trusses, and we need to understand the distinction between the three classes of structures. So we also want to be able to determine the loads in these things so we can design them and so that they can perform the work or the function that we require. Machines, on the other hand, are a little bit different. You might recognize these things as machines. Certainly the backhoe, well, it's not a backhoe, that's a excavator. The excavator is definitely a machine. You might not recognize the channel locks as a machine, but in fact they are. So how are they different from trusses and frames? Because these look like they just have members. I mean, maybe it's that they're not closed, they're open. You notice that the end of the backhoe, I keep saying that, the end of the excavator does not wrap around and reconnect to the bulk of the excavator. Same thing with the channel locks, right? They're sort of open. I guess once you put your hands on it and then grip something, then it's sort of a closed system. But that's not really the distinction between machines, frames, and trusses. But it's still important for us to be able to compute loads in the various joints and members so that they can be sized appropriately and not fail in service. All right, so here's the definition. When we're talking about a frame and a machine, here the distinction between a truss and a frame is that a frame has at least one member that is not a two-force, that is a multi-force member, at least three forces. So that's the distinction. Remember that trusses have only two-force members. So you'll notice that member ABC in this particular example could certainly have some bending in it, right? It's not simply a two-force member with forces at either end in a pinned situation. So definitely the item on the left is is a frame, not a truss, which is a two-force only containing structure. Now, machines, on the other hand, are a little bit different. So frames are usually stationary and they support external loads. Machines, on the other hand, involve moving parts that are designed to move and thereby alter the effect of forces applied to the machine. And so that's the distinction between frames and machines, is that machines are designed to move and apply force through distance in a way that changes the effect of those forces. So an excavator arm, a backhoe arm, those types of things are certainly machines for that reason, whereas the crane type of device on the left-hand side is just a frame and not a truss because it has force in the middle of a member, for example, which is not allowed in the two-force only members of trusses. Notice that machines also can have forces intermediate along the various members, and we're getting farther and farther away from members that are simply just straight rods, essentially, or things that are just straight lines almost. There's more bulk to these various components. So how do we analyze these? Fortunately, analyzing a frame or a machine is fairly similar. The key difference is that we can't always assume that there are two-force members everywhere like we can with trusses. Some of the members are going to be a little more complicated because they've got a lateral force. Like, for example, member BC has the 2,000 Newton force, which is not applied at either end of the component. And so the force at B and the force at C are not going to simply lie along a line, because for the sake of static equilibrium, they must have some components that together can resist that 2,000 Newton lateral load. So definitely this is a frame because it's not a machine, it's not designed to move around, but it does support a load and has things other than two force members. So how do you go through and analyze this sort of device? First things first, draw a free body diagram of the frame, its members, the machine, whatever you need. Draw a free body diagram, and sometimes you'll have to start the process with one free body diagram and change to another free body diagram in order to determine internal forces. But draw them as needed. One thing that helps a lot, identify any two force members, because two force members simplify things. They allow you to know a priori what the direction of the force is, even if you don't know its magnitude at the endpoints of the member. So for example, member AB is certainly a two force member, and therefore the forces at A and B on that member have to be collinear. And that helps a lot because it gives us very valuable, useful information toward the solution of the unknown forces. Another hint: anytime you have a joint that has two or more members connected to it, or that has an external force, you should usually draw a free body diagram of that pin itself. That will help you. It'll keep things straight in your mind. Sometimes you don't absolutely have to have it, but it's advisable to draw that pin. It'll make things easier. Now, another thing to remember is that forces are always equal and opposite. So if you've got a pin connected to a member and you need a free body diagram of that pin and a free body diagram of the member, remember the forces that the pin applies to the member and that the member applies to the pin are equal and opposite. And that's really important to include those in their proper sense in the free body diagram. After that, make sure you develop a strategy for applying the equations of equilibrium to the various free body diagrams in order to solve for the unknown forces. You always want to find a way to use a single equation to solve for a single unknown if possible, because that simplifies the algebra. It's not always possible, and you'll see examples of this in my other videos, but if possible, certainly you want to simplify your algebraic work and come up with some type of plan for how you're going to go through the frame or the machine, member by member, and solve for the unknown forces as needed. These problems are challenging. They're not as easy as truss problems. They're more complicated and involved. And it takes a lot of practice, so be patient on this part. Definitely work truss-type problems first to get the hang of it, and then jump to frames and machines to learn how to solve those types of problems as well.